Hi, and welcome to day 11 of the Python challenge. And today we're going to talk about regular expressions in Python. So without further ado, let's get started. So uh, regular expressions are one of the topics that we don't need a lot of background. We don't need to know all the pieces of topics that we talked previously. They can be their own topic and they can be studied separately from those topics that we discussed previously. So regular expressions are also known as regex or regexp, and the way that we use them are primarily uh, is a concise way to match strings or of text. If you're searching for a specific character, word, or a pattern, we can use regular expression to help us in this manner. So they're basically um, regular expression is basically written in a formal language that can be interpreted by a regular expression processor. So they are basically kind of a wild card for matching and parsing strings. Um, Again, uh, the primary use of regular expressions are in finding or search of a specific character or set of characters or words or phrases. Uh, they're very powerful tools that we can use, and they can be very cryptic also. Um, when we get a hold of them and we know how to use them, they become much more fun than initially. Uh, Basically, uh, they can be characterized as a language by themselves, and kind of like a very old school language of uh, computing, basically. So this is a XKCD that basically shows that if we know regular expressions, we can use it in a very effective way. We can solve problem much easier and in shorter time compared to the time that we didn't know how to use regular expression. So this is kind of a cheat sheet of which uh, regular expression do basically. So we're gonna use this quite often when we go to dive deep in this chapter. Um, Regular expressions are not part of the standard of Python, so we have to import them. So we have to use the import RE to import that regular expression library. We can use re.search function to see if a string matches a regular expression. It's very similar to the find. And also we can use re.findAll function, which is to extract a portion of the string that matches our regular expression. So this is similar to the combination of the find and slicing. For example, the variable start from 5 to 10, not including 10. So this is a bit more precise, if you will. Okay, so we are gonna use the re.search here. So what we do, we open a text file, we save it in a hand, which is our file handler. For each line in the file, we do a write strip, which means that we get rid of the character return at the end of the line, and if that line contain from with capital F and column, we're going to print that line. Now this is like a regular way of using it without using the regular expression. So we use the find function, and here we're going to import the re, which is the regular expression. We open the file, we assign it to the file handler, which is called hand, and for each line in that file, we do the same. We remove the carriage written at the right of the line, and what we say is that if we find the phrase from with capital F and column in that line, we're going to print that one. So that's basically using the regular expression function, which is re.search, which does similar function to the find function that we had here. So the result is identical in this case. Okay, so now what we can do here is we're gonna do some fine tuning. So we added this caret, and what it does, if we go back to our cheat sheet, is saying that matches the beginning of a line. So basically, if the line start with from with capital F, then we will print that line. So if we have from not at the beginning of the line but somewhere in the middle, this will not result in any output in this case. So our line has to start with capital F from with the semicolon, with the column afterwards. So this will give us a more we can have it like our search criteria is more accurate compared to one that we had here, basically. Yes. So we have a couple of other wildcard characters that we can use. So caret, as we discussed, it says that it matches the start of the line. So in this case, we are looking for lines that start with capital X. So these are all the result here. They all have capital X. Then we have the character dot. Dot means any character can be used here. And then we have star. And star means the character before it, which can be any character, can happen 0 or multiple times. So, and after that we have the column sign. So basically what this is saying is that we have X, we have, if our line starts with capital X, then we have a couple of characters ending with the column, whatever is between, we are interested, and print those lines and bring it to the by the print command. So this was a combination of different wildcard character that we used here, and we're going to use this combination a lot more as we go further. Okay, so uh, now here, so basically this is the same criteria that we had previously. The idea here is that we can fine tune our search, and based on how much clean is our data that we have, we can plan accordingly, and we can strategize our search criteria based on the environment that we are dealing with. Okay, so another way of fine-tuning our search is here. So we have \s. So \s, what it means is, so at the beginning we have caret and capital X dash, which means that any line, we are interested in lines that start with capital S and dash. So this is, see, this part is our one part that we are interested, one condition that we are interested. Then we have \s, capital S, which means any non-white space character. So if we have capital X dash space, we would not be interested in that, and that would not be in our output result. So because it's a white space character, so we don't want white space character, so we put \s, and we have plus, and plus in this case means one or more times of character before it, which is non-white space character. So if we had star was 0 or more times, but plus is 1 or more times. So again, that's star and star and plus are another way to fine-tune our matches when we use regular expression. So in this case, we're gonna have everything that is started with capital X dash, anything that is not a white space or blank, and a column. So this is going to be our result, and this, for example, is not going to be our result, because this is actually interesting, because here we said capital X dash \s, any non-white space. So this would not be in our result. So this will not be as well. The reason is we should have at least one non-white space character. So these two are not going to be printing out, but these two will be printed out. In this case, we have no white space, and we need at least one of them, so this is not an option. And in this case, we have a couple of white space, so this is not an option. These two are a correct match, and they will be printed. Okay, so there are all some other ways to do fine-tuning, basically. So in this case, we have a square bracket 0-9. So, and whatever here is, so this square bracket 0-9 square bracket, what it means is only one digit. So this is going to be representative of one digit between 0 or 9. So, but it's important to know that this is only one digit. This is not like 9 digit or 10 digit, only one digit. But because we have the plus here, it means one instance or more of this block. So here we have a number that can start from 0, and 0 is the minimum number that we can have, and the maximum number that we can have is basically 99999 till infinity. So this is quite a big range for this. So another point to remember is when we do re.search, returns true or false depending on whether the string matches a regular expression. But if we actually want the matching string to be extracted, we use re.findAll. So re.search, it just returns a true or false. If mentioning that if we have a string matching this criteria, but re.findAll will actually take out and extract that part that we are interested and brings it, basically takes it out and extract that part. So re.search, true or false, re.findOut, the actual extraction, and spitting it out for us. In this case, we are using findAll, so we will extract whatever number is in that x, which is this string. So whatever number from 0 to 99999 till infinity, it will goes and find it and put it in y. When we print y, we have a string, we have a list with 21942, which is 21942. So findAll goes find them and extract them and put them in the y. Oops, okay. Again, so we go another example with findAll. We are gonna match and extract those interesting data that we identified with this regular expression. So in this case, we have another string assigned to x. We do findAll with this 0-1 square bracket plus, which we talked about was going to be the result. We have another findAll, and we have square bracket AEIOU square bracket plus. And what does this mean is, if we didn't have the plus, only this square bracket would mean only one alphabet, one alphabet from A, E, I, O, U. But because we have plus, it means that one or more. So a word with one or more capital A or capital E, capital I, capital O, capital U. So because we don't have any of that word, if we try to print it, the result would be a list of nothing. So again, that's another way to I keep forgetting that. So basically, we don't have a word that has all vowel or sound character like A, E, I, O, U. We don't have any words, so that's why the print doesn't bring any result for us. But we have those numbers, so that's why we see those numbers coming up extracted from this string. Okay, so now there is a concept that we talk about here, which is greedy matching. So when we have greedy matching, for example, when we have plus and star. So in plus we had 1 or more characters, in star we had 0 or more characters. They are greedy matching. What it means is if we have 2 or more matching results, the Python will return the longest matching find for us. For example, in this case, we are looking for something with which is we are looking for a line that starts with capital F and any other, and I'm sorry, 1 or more character after that, ending with a column. So in this case, the first match is going to be from capital F with the column at the end, but this is the first match. But if we continue going that, we see that the space is also a match with the dot. We don't have that \s that says only so capital S is non space, basically non-blank space. But here, because we don't have it, this space is okay. So we go forward, and we get to the second column here, which matches our character, which matches our criteria here. So because this is a greedy matching, we don't stop here with the first match, we continue, and when we print the Y, this is going to be the string that we get here. The reason is because it's greedy, it goes further, even if it finds the first match, is try to go further. So now the question that comes here is, what if we are just only interested in the from? So in this case, we have to use a non-greedy version of matching. For using the non-greedy version, what we can use is to add a question mark. So for question mark, when we have question mark, it means that, okay, when you find a match, the first match is from, it doesn't continue to the next, to try to find the next possible match. After it finds the first match, it's happy with it, it just return it to us, and it doesn't go further to look for anything else. So in this case, we have the question mark, and it's a non-greedy match. So we find from, and we are happy with it, we're going to print it here. As compared to the greedy one that in the previous slide, it got here, but it went further. So that was a greedy one. This is not a greedy one. And the non-greedy one is identified with a question mark here. So that's another way to fine-tune and make sure our result is what we really need it to be, basically. Okay, so here we have another kind of fine-tuning idea that we have. So here we have \capital S plus @\capital S plus. So \capital S plus, what it means is \capital S means non-white space character. When we have plus, we have at least one non-white space character. So what does it mean is basically we have a bunch of characters, at least one of them, any character, and then we have an @. Then after the @, we have at least one non-white space character, and that's the minimum, or it can go to as many as it wants. So in this case, if we have our line here, what it does is basically, because our email address has a space at the beginning and at the end, so that's how our email address is separated from the rest of the line. The find all command function will return the email address. So this is a way to extract an email address which is separated by space by the rest of the character. So this is how we can extract that email address from this specific file. So another fine-tuning technique that we use is the parentheses. So the parentheses are not the part that are not part of the match basically, but they tell us, or actually they tell Python where to start and stop that string that we want to extract. For example, here we have caret capital F from space, and what it means that start with, if our line starts with capital F from and space, and then we get to that email address, because we have our parentheses around that email address regular expression, we just will our output is going to be only the email address. The reason is, if for example we had another line, the next line start with an email address, because it doesn't start with the from, that line would not be extracted, and that line would not be considered as interesting for our search criteria. So that's how we can put this caret from here to mention that, okay, our interesting criteria is an email address in a line that is start with from with capital F and a white space before the email address. So again, that's another way to fine-tune our search criteria. Okay, so now we're gonna have some parsing example. If you remember previously, the way that we wanted to extract the domain name of a email address was, what we would do is we would find the location of, we would use the find command to find at, and we would assign that output to another variable. When we printed the variable, we would get the location of the @ sign. So the @ sign is at location number 21. Now, if you we would do another find command to look for a blank space, starting from the position of the @ sign. So starting here, it would go from further, and here it would find a blank space here. So, and if we print that, we assign it to a variable. If we print that variable, we get 31, which is the location of that blank space. Now, what we want to do, we want to extract this domain name, which is at the end of the email address. So what we're going to do is we're going to do a slicing here. So data from the location of the @ sign plus 1, because the location of @ sign will only give us, I mean, it will include the @ sign. We don't want @ sign. We want whatever comes after the @ sign. So we just add 1 to 21. So it starts from here, including U, till the place that we saw the space. So starting from 22 to 31, it doesn't include 31, it includes up to 30. So basically, when we print that, we assign it to a variable, we print that, and we get a domain. So we talked about this previously. This is the basic way of doing this. Um, a little more concise and efficient way to do it is basically we split that line, and when we split a line we get bunch of words. So we split it, we put it on the word variable. The word 1, it's gonna be the email. So this is the word number 0. Word number 1 is this email. So this is gonna be what we see in the email. And we split the email from the @. So this is the email, we split it from the @. So this is going to be 0, and this part is going to be 1. So when we and we put that to the pieces, and when we call the pieces number 1, we get the domain name here, basically. So split, we'll split all of these to different words. Email, the output of it is going to be, the content of it is going to be the email address. Pieces is going to have the first part of the email before and the domain name, and the pieces number 1 is going to be domain name. We print that, we get this. So this is again a little bit more concise, a little bit more efficient. Now, if we want to go achieve the same result using the regular expression, what we can do, import RE, regular expression. We assign that string to lin variable. We do a find all in lin, and this is what we are looking for. We are looking for something that starts with an @, but the @ is not the interesting character. The interesting character starts from the bracket. So whatever is in the bracket is our interesting character. So here we have square bracket, caret, space, and a square bracket. What does it mean is whatever which is not blank. So after @, whatever which is not blank, it can be 0 or many of it, and that's what we are interested. So as soon as it hits a blank, which is here, that part is not interested. So whatever, start from @ till whatever it gets to the blank space, and it will return whatever is between these two. When we print this one, we get the domain that we were looking for. So this is a bit more concise and shorter version and more efficient version of finding that domain name. Again, here the caret blank means match non-blank character, and the star means matches many of them. And the parentheses means that this is the part that we're interested in, and this is the part that we're going to extract. This is the part that we're going to extract. The part that we are interested in start with the @. Okay, so again, if you want to do a bit more efficient again, so we have this caret from, which means that it has to start with the line has to start from word from with capital F. Then we have to have a space. Then whatever So dot star means that whatever is before the at sign is, for example, here Stefan, that family name. This covers that portion. We get to the at sign, and this portion we discussed already. So, but here, because we have that caret from, it means that, okay, this domain comes from the emails that are in the line that starts with capital F from. So if you have if you have this email on the next line at the beginning, because it doesn't have from space at the beginning, it does not match our criteria. Again, here's explanation that we talked. Dot star means that skip bunch of the characters. At means that looking for an at sign. And parentheses start means that, okay, this is the part that we are interested in extracting. And this portion we already talked about. Okay, so so in this example, what we're going to do is we import the regular expression library, we open the file, we put it in the variable hand, which is a file handler. We create a list, we call it num list. We create a for loop for line in the file. Let's strip the right carriage return, and what we do, we're gonna look for the start of the line would be the capital S dash the spam dash confidence colon space. So this is going to be this portion is going to be 1 digit from 0 to 9, but because we have the dot, it could be any other digit as well. And then this is on the bracket, and no, actually, I made a mistake. So dot here means actually this is an interesting one. So 0-9 dot maximum. I have to brush on this part. I don't remember exactly what this means. I want to say 0-9 dot is, I want to say dot is actually the dot here that we have at the decimal character. But this could be any, actually this could be any character. So yeah, so actually that's right. So this could be any character. So here we have one character, one digit between 0 and 9, and after that we have any other character, and we can have one or more sequence of that. So this inside the square bracket is can be 0 to 1, 0 to 9, or a dot itself, and we can have one or more of that. So basically we find this number, we extract this, and what we're gonna do, we're gonna continue that for the length of the search. So we go through that number, we find that interesting phrase, and because it happens for each line, we're gonna make sure that we we do that for each line. And as long as there is something in that finding, as long as we find something here and we put it in stuff, we continue this. And what we're gonna do, we're gonna change that to a floating number. And what we're gonna do, we're gonna append that to our num list that we created here. And so we create a list with that. That's basically the spam confidence of that file that we have. So we create a list of the spam confidence, which is a digit, and we find each of them and we put it in the list and we populate that list. And the end of this for, when we went through all of the lines of this file, what we're gonna do, we're gonna say, okay, the maximum is gonna be the maximum of this. So in this case, the maximum is going to be, we will find the maximum probability of that spam confidence based on each line search that we had. So in this case, the result would be maximum is equal 0.9907. So that's how we use it. This is only one of the values of spam confidence that we looked for. Okay. Okay, so now the question that might come is, what if we are looking for a specific sign? So what we can do is we use backslash, and backslash, what it does is says that, okay, for example, backslash dollar sign here. Dollar sign is a specific special character for irregular expression. So, but if we want to say that, okay, we are looking for actual dollar sign in our search, what we can do, we can say, we can put backslash before it, and what it does is say that, okay, backslash dollar sign means that look for actual dollar sign. And then we have here, we have 0-9 dot, which means a digit or a period, and plus, which means that at least one or more time. So here, if we have a amount of fee or value which is indicated by dollar, we look and find all of that basically, and we're going to print it here. So we are looking for this, we are looking for a number that starts, that has a dollar sign on the left of it. So that's how we put the backslash dollar sign here. So we look for the actual dollar sign. Okay, so what we talked about regular expressions. Basically, they can be cryptic, but they're very powerful language for matching strings and extracting elements from the files that we are looking for. And we learn about different characteristics and different ways that we can fine-tune and modify our search based on the criteria that we have and the situation that we have. As usual, we have to give credit to Mr. Charles Severance for these slides, and I hope this has been informative for you, and I want to thank you for listening.